Railway lost an upstream network path, recovered it, and still kept having problems because stale connections had moved onto the wrong network. Stripe says it cut database pages by about 30% by replacing hard-coded recovery logic with graph search. And a critical Kata containers vulnerability let guest root become host root. This week is mostly about what happens after the obvious failure. I'm Brian Teller from Teller's Tech, and this is Ship It Weekly. Welcome back to Ship It Weekly, the show about the DevOps, SRE, cloud, platform, and security stories that matter when you are the person keeping the thing running at 3 in the morning. For the weekly story list and source links, check out oncallbrief.com. For past episodes and show notes, head over to shipitweekly.fm. This week, Railway published the RCA for a major US East outage. Stripe shared how it uses graph search and state machines to automate database remediation. Kata containers patched a critical guest-to-host escape, and DynamoDB now has native vector search. Then we have 3 quick lightning stories and a closer about learning cloud-native engineering by actually working on real systems instead of just finishing another tutorial. Let's get into it. First up, Railway published the incident report for its July 2nd US East outage. The incident started with an upstream ISP problem. That alone is not especially unusual. The more interesting part is what happened next. Railway disconnected the affected carrier, but in the process, it also removed the site's last default route. Storage traffic then fell back onto a management network that was never intended to carry that load. Eventually, the routing problem was fixed, but recovery did not mean everything immediately went back to normal. Some long-lived connections had already established themselves over that slower management network. They stayed there. So even after the main route came back up, some traffic continued using the wrong path. Railway also described around 20,000 private network connections ending up black holed during the incident. This is one of those failures where the original trigger matters less than the state it leaves behind. We tend to think of recovery as a binary thing. Route is broken, route is fixed. Incident over. But distributed systems do not always reset themselves just because the thing that caused the problem has been corrected. Connections stay open. Caches preserve bad information. Sessions remain pinned. Retries build pressure somewhere else. And the failover paths can quietly become the new steady state. That is the lesson that I like here. When you restore the control plane, you still need to ask what data plane state was created while things were broken. What connections need to be recycled? What caches need to expire? What sessions need to be re-established? And what fallback paths are still carrying traffic they were never supposed to handle? The first fix gets you out of the fire. The second part is making sure the system actually returns to the architecture you intended. Next, Stripe shared how it reduced database paging by replacing a lot of hard-coded remediation logic with something much more dynamic. Stripe operates a large MongoDB fleet, and like a lot of mature infrastructure, recovery used to depend heavily on specific runbooks and rules. If this condition happens, run this action. If that action fails, try this other one. That works, until the number of possible states gets large enough that the runbook itself becomes a system you have to maintain. Stripe's newer approach models remediation as a graph. The current state of the database is a node. Possible recovery actions are edges, and the system can search for a safe path from the current broken state toward a healthy one. They combine that with state machines to track what is happening, and Dijkstra's algorithm to find possible remediation paths. The result, according to Stripe, is roughly a 30% reduction in database-related pages. They also reported around 200 fewer pages per year and fewer days where shards stay unhealthy. What I like about this is that it is not really an AI story. It is an automation story. We sometimes jump straight from manual runbooks to give an agent access to production. There is a huge middle ground between those two. You can model the problem. You can encode valid state transitions. You can define which actions are safe, and then let software calculate the recovery path without making the recovery system completely open-ended. That is a much more interesting form of automation to me. It still gives the system flexibility, but the flexibility exists inside boundaries engineers actually defend. And just as importantly, the recovery logic becomes something you can reason about. You can inspect the graph. You can test transitions. You can understand why the system selected one path instead of another. Automation gets much more useful when it reduces toil without also reducing explainability. Third, Kata containers patched a critical guest-to-host escape. The vulnerability affected the runtime RS virt.io.fs path. In the affected configuration, root inside the guest could cross the isolation boundary and end up executing as root on the host. That is about as bad as container isolation bugs get. Kata exists specifically to strengthen the boundary between a workload and the machine underneath it. Instead of relying only on normal container isolation, workloads run inside lightweight virtual machines. So when a vulnerability crosses from guest root to host root, it is attacking the exact security property people adopted Kata to get. Affected versions run through 3.30.0. The fix is in 3.31.0. The practical takeaway here is pretty simple. If you are running Kata containers, this is not a patch that I would leave sitting in the normal backlog. But there is a broader point too. Isolation technology changes the attack surface. It does not remove it. A VM boundary is stronger than a namespace boundary in a lot of scenarios. But virt.io, shared file systems, device emulation, runtime components, and the glue connecting guest and host all become part of that trust boundary. Every time that we say that something is sandboxed, the next question should be, by what? And what still crosses that boundary? Isolation is not a checkbox. It is an architecture. Fourth, DynamoDB now supports native vector search. That means that applications can store embeddings and run similarity searches without automatically reaching for a separate vector database. For teams already using DynamoDB, that can remove a surprising amount of architecture. Today, a common pattern is to store application data in one system, generate embeddings, write those embeddings somewhere else, and then keep both stores synchronized. Now, you can potentially keep the primary data and vector representation closer together. That is attractive for things like semantic search, recommendations, retrieval augmented generation, and agent memory. But I would not read this as vector databases are dead. A specialized vector engine may still be the right answer if vector search is the core of the workload, or if you need capabilities DynamoDB does not provide. The interesting part is that vector search is becoming another normal database feature. We have already watched this happen with JSON support, full text search, caching, analytics, and other capabilities that once demanded separate systems. That usually leads to a good architecture question. Do I actually need another service? Every additional database creates another backup strategy, another availability model, another security boundary, another cost center, and another thing someone has to understand during an outage. Sometimes that complexity is justified. Sometimes the best infrastructure decision is deleting a box from the diagram. Quick lightning round. First, AWS brought explicit proxy functionality into Network Firewall. That gives teams another way to control outbound traffic while keeping firewall rules, intrusion detection, TLS inspection, and workload-aware controls in the same general system. There is also a new no-source preservation mode that can work with NAT Gateway. Useful, but as always with AWS networking, look closely at the traffic path and processing costs before you decide the cleaner diagram is also the cheaper one. Second, AWS API 1.6 makes TCP route and UDP route stable. That matters for workloads that are not HTTP. Databases, queues, game servers, DNS, and other Layer 4 services can now use stable Gateway API resources instead of treating Gateway API as mostly an HTTP routing story. And third, Containerd 2.4 is in beta. The release includes work around warm image caching, runtime introspection, snapshotters, and other internals, along with some breaking changes. If Containerd sits underneath your platform, beta release notes are worth reading early. The worst time to learn that something you depended on disappeared is during the Kubernetes upgrade that also changed 6 other things. The human closer this week comes from a developer writing about getting deeper into cloud native through the LFX mentorship program. What stood out to me was not the specific technology, it was the progression. Documentation work leads to actually deploying things. Deploying things leads to debugging OpenTelemetry and Prometheus. And debugging leads to understanding why the pieces behave the way they do. That is where most engineering knowledge really comes from. Tutorials are useful because they remove friction. Everything works in the order that the author expected. The YAML is correct. The versions match. The network behaves. And the command in step 7 produces the output shown in the screenshot. Real systems do not do that. A real environment has the wrong version. The collector starts, but exports nothing. The service account technically exists, but does not have the permission you thought it had. The dashboard is empty. The example in the documentation was written for a different release. And now you have to figure out why. That frustrating part is where judgment starts getting built. You stop memorizing commands and start building a mental model. You learn which logs matter. You learn what assumptions to check first. You learn what healthy actually looks like. And eventually, you get faster. Not because you know every answer, but because you know how to narrow the problem. That is one reason that I think contributing to open source, mentorship programs, labs, and even small personal projects can be more valuable than stacking another 10 hours of tutorials. You need environments where things can be wrong, because production is mostly an environment where things can be wrong. There is nothing bad about starting with the happy path. Just do not stop there. The goal is not to finish the tutorial. The goal is to become comfortable when the tutorial stops matching reality. That's it for this week of Ship It Weekly. We covered Railway's US East outage, Stripe's graph-based database remediation, the critical Kata containers escape, and DynamoDB native vector search. Plus, AWS Network Firewall Proxy, Gateway API 1.6, and Containerd 2.4. Follow or subscribe wherever you are watching or listening. You can find the weekly story list and source links at oncallbrief.com, and past episodes and show notes at shipitweekly.fm. I'm Brian Teller from Teller's Tech. Thanks for listening. And remember, recovery is not finished just because the original failure is gone.